right, so we are going to finish lesson 4.1. So today is day 2. Let me present my screen and I'll get started. Okay, so we're going to pick up with these extra practice problems. I guess I have to make this a little smaller. I did the odds last time, so I'll work through the evens this time. Make sure you're working along with me, thinking through the problems, maybe even trying to work ahead of me if you can to see if you can figure them out on your own. All right, so for problem number 1, we're asked to name the vector and then write its component form. So the vector at point M, that's its initial point. Its terminal point is point N, so it's vector Mn. Its component form, movement of the vector, we're moving 1, 2, 3, 4 units to the right and 1, 2, 3, 4, 5, 6 units up. So 4 units to the right and 6 units up are both positive values. Right. For number 3, the starting point is K, the terminal point is J, so this is vector Kj. And it's moving 1, 2, 3, 4, 5 units to the left and 1, 2, 3 units up. So it's a -5, +3. Okay. All right, let's move to the next set of problems. All right, so if you remember last time, we are counting by 4s, so be careful with your scale. I'm going to first draw the triangle that's given, the pre-image ABC. A is located at 1, 2, that would be about here. B is located at 5, 1. Come on, there we go. And C is located at 5, 4. Right, so this is C, this is B, here is A, and this is our pre-image, our original triangle prior to any transformations, right? Now the component form tells us how to move, how to translate, how to slide the triangle. So for number 4, we're moving at 4 units left and 0 units up. So as far as coordinates are concerned, I'm going to subtract 4 from each of the X values. I'm going to add 0 to each of the Y values. So A prime, subtracting 4 from the X, so 1 minus 4 is -3. Adding 0 to the Y leaves me at 2. For B prime, subtract 4 from the X, that's going to give me a 1, and add 0 to the Y, that's going to give me a 1. And C prime, subtract 4 from the X, that's going to leave me at 1, and add nothing to the Y, so that's going to leave me at 4. So plotting those points, -3, 2, right here. You can see I was translating it to 4 units, right? We have to jump by 2, 4 to the left. The next one is 1, 1. That's B prime. Oh, I went too high. Sorry. Gotta back up. Gotta back up. Oh, darn. I'm gonna have to erase that for a second. So this should be A. Try that again. Plotting B, 1 to only go over half, and 1 go up half the way. This is B prime. And then C prime is 1, 4, which is here. C prime. So I have A prime, B prime, and C prime, and I can connect them to draw my triangle, okay? And then maybe I'll leave that there and I'll do the next one in black. It might get a little messy, but that's okay. So here I'm gonna have A prime, B prime, and C prime. The rule that I have to follow says move all the points 1 unit to the right, so I'm gonna add 1 to all the X values. So that's going to be a 2, a 6, and a 6. 2, 6, 6. And then I'm going to subtract 3 from each Y. So that's going to be -1, subtract 3, that's going to be -2, -2, and subtract 3, that's going to give you a 1. Okay, so plotting the first point, 2, 1, it's right there, it's A prime. Then I'm going to have 6, -2, B prime, and 6, 1. That's C prime. And there is that triangle after the translation. Okay. All right, let's keep on moving. Oh, just make this a little smaller. All right, for number 8, directions say to write the rule for the translation that maps P, Q, R, S onto P prime, Q prime, R prime, S prime. So it's a translation that moves all points X comma Y onto, well, now we have to figure out what the rule is. So pick P and move to P prime and count units. 1, 2, 3 to the, 1, 2, 3, 4 to the right. 1, 2, 3 up. Let's see if it's the same for S. 1, 2, 3, 4 to the right. 1, 2, 3 up. Check for Q. 1, 2, 3, 4 to the right. 1, 2, 3. And R, 1, 2, 3, 4 to the right. 1, 2, 3. So I'm moving all my points 4 units to the right and 3 units up. Okay. All right. For problem 10, we're going to apply the rule to the given coordinate. They're telling you to find the image of J, so that means J prime is what I'm looking for. After I move all points 6 units to the right, so I'm adding 6 to all the X's, and 3 units down. Subtract 3 from the Y's. Okay, so 6 and a 4 gives you a 10. 5 minus 3 is going to leave you at a 2. All right. And the last problem. Okay, here it says, in a video game, you move a spaceship 1 unit left and 4 units up. Then you move the spaceship 2 units left. Write the composition as a single transformation. Okay, so let's think. I gotta get my pen. Let's think about this. All right, so I'm going to be translating all points X comma Y, and I'm mapping on to a new point. And again, and so you have to move all points 1 unit left. So I'm going to start by subtracting 1 from the X, and then, excuse me, 4 units up. So it's going to be Y plus 4. But then it also says, then you're going to move the spaceship 2 units left. Okay, so if I'm moving 2 units left, that means I'm going to then have to subtract a 2 from the X. All right, so I'm going to simplify this all. I'm going to kind of combine like terms and clean it up a bit to get my single rule. All right, X minus 1 minus 2 really means I'm moving a total of 3 units to the left and then just the 4 units up. That is your single transformation rule for this composition. Right. Okay, let me just look at the next page, see if there's anything new that I want to do. No, they're all new. All right. Actually, let's go to the next page just for 4 quick problems, then we'll be done. The top 4, okay, it says tell whether the transformations appear to be a rigid motion explained. So remember, rigid motions are transformations that produce an image that doesn't change the image's size or shape, okay? So basically all the angle measures are preserved, are unchanged, and all the side lengths are preserved, are unchanged. Okay, so does your pre-image and your image, do they look like, even though it looks like it was rotated, we had to turn it, does it look like the image is still the same shape and same size? Yes, okay, and that's because a rotation is a rigid motion. All right, let's go down to 4. All right, number 4, it only looks like we flip it, right? We reflect it. Does the shape still stay the same size and shape? Yes, and that's because a reflection is a rigid motion. Okay, so I guess we could write that. A rotation is a rigid motion. A reflection is a rigid motion. Let's go over to number 3. Here's my pre-image. Here's my image. Okay. So it looks like we may have just translated. Honestly, we could have reflected. We could have rotated, right? It kind of depends. We're going to call this one a translation since we already talked about rotation and reflection in the other one. And yes, the image still looks the same shape and same size. So it is a rigid motion. That's because a translation is a rigid motion. The last one, does the image and the pre-image, do they look like they're the same shape, same size? Looks like the same shape, but not the same size. So no, it's not a rigid motion. And that's because this is most likely a dilation, and a dilation is not a rigid motion. No, a dilation is not a rigid motion because the figure changes shape. Distance is no longer preserved, right? Okay, and that's going to be the end of the lesson for today. So, where are you guys? Here you are. So that's it for lesson 4.1. I'll see you guys back here for the next one. Bye.